Let's start with this one. Well, Solidity, as any of you who knows about Java programming, it actually looks really similar to it. It's kind of a mix by Java, some like TypeScript and Python, but it's not a hard language, to be honest. So you can just learn it from anywhere you want. It's basically free to learn. A lot of stuff is also doing
Is
this.
it object-oriented either?
Yes, it's object-oriented.
Okay.
Yeah, so I have a very basic smart contract, but before I actually deep down into this stuff, let me just give you a brief explanation of these things. So, as I said, and everything you coded, so you can just make a code and deploy it. And by I say deploy, you're actually gonna send this contract, this code, to the Ethereum virtual machine, and it's gonna be living there forever. And unless you have a function to delete it. Well, then anybody can actually interact with it, even with a front end or from somewhere else like Etherscan or like a Truffle, Brony, this kind of local environments. So is there any other thing? I guess no. Yeah, so actually let's look at this one. So you'll see here, there's this thing called Pragma Solidity, which actually tells you which edition that you're using the Solidity. So I think it was the latest one. That's why I typed it here. So this is a must. You need to do it. And just like Java, every time you do finish a line, you put a semicolon. And yeah, and just like you said, instead of classes, we have contract. So you should definitely have this contract counter or any name, whatever you want to just put down there. And then you're going to type all the things inside of those brackets. And also just like Java, there's a constructor, which will be the first thing that the function, the contract will do when it deploys. And that also means it's irreversible, because you will be only have a chance to do that only one time, because you're just gonna deploy it once. Yeah, so basically when you type your code, and also the remix is good, if you just put something like this, it will say the errors and stuff. I think it's a really smart way to do smart browser language, I guess. So let me just compile it. So every time you do it, you're just gonna come to the here. What is it? Yeah, this thing over there. You're just gonna click that, and you're just gonna find your compiler. So in our case, I'm using this little thing over there, this bracket. That means use the latest one for the 8 series. So you're gonna just change it whatever you want. So in my case, it's the latest one, so I'm choosing the latest one. Then I'll compile it, and the reason why this compiling thing is you actually compile your code. This is a high level code, so you're just actually gonna make it understandable for the blockchain. So you don't need to know the details, I guess, for now. But once you do compile, if it's not compiled, let's just do like this, for example. Yeah, so it shows you why it cannot parse it, cannot compile it. So you make sure that there's no errors, and then you will be able to compile it. And then after you compile it, you're gonna come to the here, say deploy and run transactions, that button over there. And you will see this thing called environment. So in default, you should be using the JavaScript virtual machine London. So what is it? Basically is it's like a fantasy blockchain where you can test and do stuff. You're not interacting with the real chain or any testnet. You're actually interacting with the Remix's virtual machine. It's like a fantasy blockchain, as I said. And those two things, maybe I can tell it later, but just for now, you just pick one of them, London or Berlin. I suggest you to use London. Then you'll see a bunch of accounts here. So these are the accounts that the Remix is giving you, so you can just play around with your code. So you can just switch accounts by just doing this, and you can see they're all pre-funded with 100 Ether. So It's a good feature. And let me go to this one. You don't need to change anything in the gas limit. This is a bit advanced topic, so I'm not going to talk about it as well. Over here, we have value and way. So maybe you don't know about those things, but it's basically, so 1 ether is 10 to the power 18 way. So it's just like a meter and kilometer kind of thing. And I don't know what I think G-way should be 10 to 9. I'm not quite sure, but way is the most popular one. So you should definitely know this one. And actually, let's keep that thing here. And then if you compile successfully, you can just come here and say deploy. And once you deploy, and here you'll see a console. It says you did it, and it's going to actually show you the data. So this is the transaction hash from this address, which is this address. And you can see my Ether amount in the first account is actually got lessened, because every time you send a transaction to the blockchain, you need to send some gas. So anytime you actually change something or anything you do in the storage in the virtual machine, you're gonna need to pay some gas. And the complexier it is, then the higher amount of gas that you will have to pay. So yeah, you can track those things over there. And then let's try to do it. So here it says deploy contracts. So just pop this thing up and you'll see decrease, increase in value. So what are those things? So in Solidity, we don't do like a code that flows all the time. You know, most of the time, actually, let's say 95% of the time, you might need to do a bunch of functions inside of here that the people or whoever is going to interact with that contract can call it externally. So we have two functions and a constructor and an integer, a global integer here called value. So if you, as in Java, if you make this public, then you can use it inside of here, and you can use it inside there. So it's in the storage. So when we deployed it, we set that value to 0, and you can just come here and call this one, and you will see here it says 0. Actually, let me tell you why we use uint. I forgot that. So uint is the numbers from 0 to infinity. I mean, the only positive numbers. In Solidity, you cannot use decimals. You cannot do this and not this. I mean, in some out scenarios, you can do that, but just for now, know that you cannot use those things. And the way thing is actually for using the decimals. This is a bit advanced things, but I think we can get to that at some point. And then you'll see the colors. So you see this is blue, and when I click it, it just immediately do something here. It's called. So you can send a transaction or you can call something. So if you can call something, then you don't need to pay any gas. Even though your gas limit shows you need to pay some gas, you actually are not going to do that because the Ethereum virtual machine is going to refund you. So if you're not changing anything in the storage, then you don't need to pay any gas. So I'm not changing anything in the storage over here. I'm just checking the value of the value. So let's say I want to increase it. Now, if I increase, as you see, I need to increase the value. So let's click that one time, and you'll see we send a transaction this time. And this actually shows the gas. I mean, it's not a realistic estimation, but it's good anyways. And then if you can call the value one more time, you'll see it's changed. And if you can say decrease, and value is going to 0. And you can just put increase millions of times and just 6. So that one was I think the most basic thing I can show you. And I have another example, but before that, you guys want to ask me any questions? I guess no. So I'll go with it. All right.
Aslında benim bir sorum vardı.
Yeah, okay, go ahead.
Mesela NFT'lere de akıllı kontrat uyguluyorlar ya. Peki Mesela 10.000 tane NFT olduğunda hepsine ayrı bir kontrat mı uygulanıyor yoksa aynı kontratın üzerine işleyebiliyorlar mı onu?
No, it's actually going to be only one contract that's going to mint. In minting NFTs are ERC 721 standard tokens. So they're actually token, non-fungible token, as in the name.
Yeah.
Where you have only initial supply of, as in your scenario, is 1,000, then you can only mint to like 1,000. So there is only one contract that doing this. There is only one minter. I mean, not one minter specifically, but it's one contract. It's basically ERC 71. If you want to know about those things, you can just take that note. You can check it in the web. Yeah, you'll see it.
Okay.
Any other question?
I have two questions indeed.
Okay.
Let me ask before Rish's question. Does anybody have an expertise, like have a familiarity with Solidity or smart contract programming? So everybody's new here, right? In this area.
I mean,
Mohammed,
yeah, a bit. Yeah.
Got it. This thing might be a little bit first confusing since it's your first time. So we'll send you some videos you can more get expertise by watching them and stuff. But this is mostly Murathan's videos and explanatory is for you to jump into it, like at least a bit and you can, grasp things fast, right? Compared to not knowing anything. So
exactly.
So yeah, somebody had a question. Rushdi, you had, right?
Yeah, basically I would ask the same question. First of all, why would I need these codes and these operations from point of business? Second one, from point of engineering, where would I deploy these codes in order to run or to be effective indeed?
The first one, you see that there are like millions of projects, like finance projects, or even the ones that the Yarkan was talking about, the tokenomics. So how do you do that? That was a pie chart, if you can recall. Like how can you do that allocation? So it's all in the code. So you need a contract. So for example, in Yarkan's case, there was a treasury. So you need a treasury contract where it just do the funds. Maybe it's something like this. So if there is 100, you say the 10% stays for staking. And what is staking? So, all right, so you need to do that for function stake. So anytime you actually go in your web browser, go to that application, you need to call that stake function via the front end. Then you're going to do it when you try to stake your tokens. I don't know, maybe you have 1,000. You're just going to give the parameters, and it's going to do a bunch of functions over there. So all of those things for the DeFi projects or NFTs, gamings, or not even anything related with DeFi or NFT, anything you want to build, you can do that. Even this one, I mean, it looks like a pointless thing, but who knows? You can do a voting system where everybody can see their votes, because everything you do in the blockchain, every contract, so you can go there and check it out. So for example, you all know this Etherscan, I guess, or not. This is a blockchain explorer for Ethereum. So for example, let me go here. This is my developer computer, so that's fine. All right, don't even know my password. Great. Yeah, so if I can do that, so this is my MetaMask account in my developer computer. So if you can hear, if I just do this and click it, and you see this is my account. I mean, you cannot see any contracts over there, as you see, because this is an EOA account. So in Ethereum virtual machine, there are two kind of wallet addresses that you can see. One of them is you'll see as EOA, which is externally owned account, just like a wallet address. So wallet address, Binance address, these are the EOA, personal wallet addresses. And the other one is the smart contracts. So for example, let me go the way before. Yeah, that was the contract that I was working on. So you can just go there, and this time you can actually see a bunch of things. It's contract, events, analytics, comments, and you can see all those functions over there. So this was the Yan Finance USDC Vault, and you can see the deposit, withdraw. So all of those things are triggered by some users. So what happened is, actually, let me demonstrate that. It's going to be a complete answer for your question. So if you can go, so this is a DeFi where you can, like a DeFi application. What I was looking at it is this one. Yeah, so as you can see, this is a USDC thing. If you put your USDC over there, it gives you this much of percentage. It's 3.22. So you put here your money like that, and you approve and deposit. And once you do that, you're going to see your thing over there. And in the contract, you can see what's going on like that. Let me show you the deposit function. Yeah. So when you go here, you're going to enter your amount you want to do. For example, this much. And you're going to approve and deposit. And once you click that deposit, you're going to trigger that function over here, the deposit function. So if you know how to code, or if you understand the code, you can just check the code if it's valid or not. So as you can see, there are a bunch of codes, and this is it. So I hope you got the answer.
Yes, clarified very much. Thank you. Thank you, Murathan.
Thank you. I guess you had one more question.
Where would I deploy these contracts?
Yes, so you
So
deploy those. All right,
Ethereum,
go ahead. Sorry for that. Go for that.
Yeah, I guess Ethereum virtual machine, right?
Yeah, if you are in Ethereum blockchain, Ethereum mainnet, I mean, in Ethereum, as you can go here in a MetaMask, yeah, you see this Ethereum mainnet. I mean, I added lots of networks here, but you should see those colored ones. So the Robston, Cowan, Rinkeby, Goerli. So these are the test nets, and the test nets purpose is test the thing before you actually launch it in the mainnet. Because remember that if you want to deploy a contract to the mainnet, then you need to pay some gas in terms of Ethereum coin. So you need to make sure that everything is set and ready. So you do your test over here, you do your test over there, you do your test on any kind of environment you want to do, Python, TypeScript, JavaScript. So you're just going to make sure that everything is working, because once you deploy it over there, there's no way you can change it. You need to redeploy it. And if the people are already deployed over there, so for example, there are $300 million, and if there's a leak on it, and they cannot do anything for this. So testing is a really essential thing in smart contract development. And that was a bonus information.
Thank you very much.
All right. I have one small example. I coded this one just a few hours ago. I call it piggy bank. We have a piggy bank here. So, I mean, it's basically as the same thing. So first things first, just do this one. And let me tell you this one, this is the license you need to use. You don't necessarily need to use it, but it will tell you you don't use any license. And to be really honest with you, I don't know what's working for. I think that's my bad. I just always do this one or sometimes another one. You can just copy paste this one or just skip it. It's not going to throw any errors. So as in usual, you need a contract, just like class. So I call this piggy bank and it closes over here. Then I have an address thing. So for the Web2 developers like Java guys, you can see this. What is address? Address is basically a string, a bytes array for addresses. So you can store addresses inside the address, just like string, just like uint. This is a Solidity feature. So for example, this is my address. I can store this. So I can just do that. Address is equal to this. And of course, like that. Yeah, like that. Okay. So you can do that. So the address holds addresses. Then I have a mapping. You know the mappings like hash mapping. It has a key and the other thing. So what you can do is 11s, then say my address, which is Murathan, is going to be 0 kind of thing. You don't necessarily need to do that. I just needed that for this example. So let's go ahead with the constructor. So as I said, you can only do the constructor once, since you're going to only deploy that once. And you'll see something here called message.sender. So this is a global variable for Solidity language. So message sender means whoever calls the function. So if I would have deployed this, let's actually compile it first. And because I compiled it before, it's already compiled. When you do that, you're going to see it's compiled or not. Then you're going to come here and you're going to deploy. So let's select the first account and select the contract that you want to deploy, which is the piggy bank contract. Then when you deploy over here, or actually, let me make this, okay, it was actually, I forget that one, so sorry. Let's deploy this and click here and you'll see the admin. And if I click the admin, it's gonna give me an address and the address is the same as this one. Because I deployed it, so the message sender literally means whoever calls the function. And in that case, constructor is only called by the guy who deploys it. So it's the only admin. All right. So we have something called modifier. These are the things that beginner level things. This is why I actually want to tell those things. You will see lots of things like this one, modifier and stuff. So I'm just telling you to not get familiar with this one. So the modifier can use on the functions just like here. So external only admin for only certain people can call that. So for example, this delete allowance function is external. So external means that it can call by public. You can call, anyone can call that, but it's also have a modifier called only admin. So what does that happen in this function is basically this one. So you're gonna read this one, you're gonna come here and you're gonna read this one and you're gonna go ahead with that one. So basically that's what's happening. You can come here and do that. So this is the same thing as this one. But what is require method? It's also a Solidity thing. Require is checking for a Boolean. So if the message sender, whoever calls the function, is admin, go ahead and do the other options. Do here, do here. But if it's not called by it, the admin, then don't do anything, like throw an error. So I can just show you like this. So remember, this is the admin account. So let's take another account and try to delete allowance and just address is over there, pen. And you see it says an error. And you can see the revert message, I guess. Where's the revert message? Yeah, you're not admin. It says you're not admin because I added a string here. That string is just giving the developer what he doing wrong. So as you see, that transaction got reverted. It mined, but execution failed, and it says you're not admin. You're not admin. Let's go ahead with this one. So our piggy bank can, people can deposit the money into that contract. So you don't necessarily need to send your money from peer to peer. I mean, this is a little bit a weird thing because everybody says peer to peer and peer to peer, but you don't need to do it. So peer to peer means that you're sending the funds from an externally owned account to externally owned account. But in some cases, you can send from your wallet, which is you are an externally owned account, to a smart contract, which we will going to do here. So I'm going to send this money to that contract. So just to demonstrate this one, so you remember this USDC wallet from Yan Finance. you can check here on how much USDC coin that they have. So this smart contract, it's not even owned by the admin. Admin is the only one who deployed that one. And you can see there are a lot of funds here. $56 million worth of USDC coin is sitting in the contract. So you can send funds and you can take funds from the contract. So in here, in deposit ETH, I'll send some ETH to that contract. And there is a thing called payable. So if you are sending Ether, you must have this payable method. So you need to add that. If I would delete it, it will tell me. And you can see it's really explanatory. It can only be used in payable public functions. So, all right, let's do that. And how do we send the money? Good. So let's take the second account and let's take this here in Ether, and you will see a value. So you're going to send the message with a value on it. So let's say 1 Ether, and I'll come here. Where is the deposit ETH? Yeah, I'm going to click that, and you see it is successfully done. So now I want to check how much this contract has. But did I make a contract like that one? I didn't, but I'm going to show it later on. Okay. So now when I do that, when I deposit ETH to that contract, my allowance is now 1. And how can I see that? Is I can copy this one and I can over there and say allowance. And now you'll see a lot of zeros. And that's the reason that I told you. So I send 1 Ether. So 1 Ether is 10 to the power of 18 way. So everything you see over there with a bunch of zeros, actually divided by 10 to the power of 18, and you'll see the Ether value. Yeah, so I can just send it over here, and you can see that 1 Ether is gonna left. So what if I can send like 10 Ether and deposit, and now you see it's 88, like I'm giving out the Ether to that contract. Yeah, so then we can withdraw, of course. And there are a lot of required methods that I was talking about. I actually chose these ones because when I first started learning Solidity, those are the things that were giving me troubles. This payable thing, the public thing, and the message value, message sender, and especially the require. So as I said, let me repeat, require is checking. It's like an assert method in Python. So if the message sender, which whoever calls the function, is not admin, then don't execute the further code. Don't do the line 14, don't do the line 15. And then over here is the same thing. So if the allowance message sender, which whoever calls that withdraw ETH function, doesn't have any allowance, then don't do those things. And over here, what I basically do is I transfer the Ether to the payable to account and doing this. So I don't want to actually go in more details on this one. I think it's a lot of information already. But basically that's it. That's how you do a piggy bank. And I can just share this code and you can just try and work it around and stuff. Oh, I forgot these ones. Let me tell this one too. So these are fancy functions. There's receive and fallback functions only needed when a contract is actually receiving any Ether or not. So in our cases, we're sending the ETH to that contract. So that contract must have a receive function and a fallback function if you want to transfer. So actually, let's delete this one because this is going to confusing. So just know that receive is enough. Fallback is another thing. If you're curious about that, you can just go it and learn it. But in our case, it's actually not needed. I just noticed. So you can call the receive. If you have a receive function like this one, that means this contract can receive Ether. And also, yeah, I did a purposeful mistake over there for those of you who wants to know about the contract security as well. Actually, in that code, there's an exploit, a very popular exploit. So if you are willing to take that, your chances, I can send it over. And yeah, I guess that's enough for me. Do you have any questions in this part?
Yeah, I do. For the smart contracts, like, can we create a database inside a smart contract? Like,
can you repeat it again? I couldn't hear you.
Like creating a database inside, creating, let's say, multiple users inside one smart contract. It's like a database, basically. Can we do that?
You can. You have a storage unit in Solidity. You can store anything inside of this contract. But remember, like the more you use the storage, the more you pay the gas. So you should always avoid like for loops, while loops. I mean, like 100% sure you won't see any while loops or catch and try, something like this. While it's not true, execute the function millions of times. This is like very unlikely situation. I never seen it in my whole career, let's say, because if you do more computation, it's gonna cost you a lot of gas, and you can just test it by make a for loop, call a function, and make another function with no computation at all, and then check this one over here, and you'll see the gas one over there. But don't check this one. You check this one, the execution one. Oh, this one is the gas limit.
Okay, and what about like the good practice of this? Let's say if I want to do like an authentication system using public key and password, for example, I cannot like create mapping users and do whole of it.
Yes, you can do that. So this is a bit of an advanced trick, but since you asked, let me tell you. So mapping, you will see very popular because mappings are actually read-only. So the Solidity, in contrary to the JavaScript and Python, it doesn't hold in the mappings in the storage. I mean, it holds this in the storage, but it's just read-only. So instead of doing arrays, you should always do mappings. And you'll see it once you test with the same thing, do with the mapping and do with an array, and you'll see the gas fees, and you'll understand that. So it's just read-only. So you don't need any for loops for detecting an element in the mapping. Only thing you need is this one over there. I hope that one is answered to your question.
Yeah, I got it. But I mean, is there any good way to do this other than doing mapping inside a smart contract?
Well, you can do mappings to hold some data for users. You can use arrays if you're willing to pay the gas, if you're okay with it. I mean, for Ethereum, I don't think you should do that because the gas fees are huge. But if you have a really cheap network, then you can do it. Or you can hold data as signatures, as cryptographic things. You can just take the signature of a user and store it on front end or back end, whatever you want, or just make the user hold it by itself. Then you can use it. But I think what you say is, I think you have a bunch of options. These are the ones that I actually get in my mind now.
So basically, like storing the actual data in a database, and the hash of it, we will store it in the smart contract.
Yeah, that can work. Or you can store the hash as well, or you can store the message, the address, the message. You can just store those two in the backend or front end, and then you can make some functions to receive the cryptographic hash for the specific thing, and you can call the function for it. If you want to know what those things, check this one. Actually, or check Merkle proof. I mean, I hope that things are going to help you, but these things are a little bit advanced. So,
okay, all right. And and one last question about the concept of rug pulling. Sometimes the NFT collection can rug pull the whole project or the token. Can developers like unlock after locking the market supply or the total supply?
Well, this is a very general question, to be honest. I mean, you can do a lot of things, and you need to see the contract. Like if you're allowed to call a function and just change everything, or is it something that you cannot do even you're a developer or even you're the admin? So I think the logical way for you is just go to the contract address, find the contract address where you want to do, go to the explorer of that chain, check the contract yourself, like if it's something that can be callable by an EOA. And over here, you cannot call withdraw, like, I know it's gonna be a little bit advanced, but I just wanna. You check it from the Explorer yourself and see, because this is a very general question. I can make an NFT contract and I can have a function that only allows me to mint all the NFTs kind of thing. So, yeah, so it's not like everything is standard and same. And that's why there are a lot of rug pulling is happening every time, like every day.
I mean, my question was like the actual developer. Let's say, for example, I created a token. I've locked it, for example, for 3 years. Within the 3 years, can the developer like unlock it, change the timing?
Yeah, I just answered this one, to be honest. You can or you cannot. I don't know. It depends on the code.
Okay. So it's doable.
It is doable.
Okay.
Why not?
All right.
Any other questions?
Benim bir tane daha sorum olacaktı aslında. Peki bir akıllı kontratı yazdıktan sonra değiştirebiliyor muyuz? Mesela bir DAO'ya aktarabiliyor muyuz? Gelirin %30'unu ya da benzeri bir sisteme.
Yeah, nice question. To be honest, if you would have asked this like 2 or 3 months ago, I would say no. But now there is a way. That's actually really, really new technology. Not really, but it's been, I think, 3 or 4 months that's been introduced. In general, no, you cannot. So anything you deploy over there, you see. So if I would have deployed this, I cannot change it. I cannot do anything over there. But there is something called this. If you want to know, you can just take this note, but it is a very advanced thing. So let me just type it. Open Zeppelin up. So you can make some proxy contracts. I mean, I would love to tell you this, the details of it, but it kind of feels like an advanced thing. So, if you can ask this question in my private time, I can tell you what this thing does. But generally, there's 2 contracts, which one is doing the thing, and the other one is holding the storage. So you're actually only changing the proxy, and the storage remains the same. It's a bit complicated thing. If you want to know the deep details, you can just type it down. Or all right. Any other questions? I hope you're satisfied. Okay, I guess no questions. All right, Mehmet Hocam.